Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. Now we will start the unit 9 hydrogen, and in this video we will discuss about position of hydrogen in the periodic table and occurrence and isotopes of hydrogen. First of all, position of hydrogen in the periodic table. Hydrogen has resemblance to alkali metals as well as with halogens. Now see in what way hydrogen can resemble to alkali metals. Resemblance to alkali metals. Its electronic configuration is 1s1, which is similar to the outer electronic configuration ns1 of alkali metals. It loses one electron to form unipositive ion as alkali metals form. Like alkali metals, hydrogen forms oxides, halides and sulfides. But in some of the properties, hydrogen show dissimilarities to alkali metals. And these are, unlike alkali metals, it has a very high ionization enthalpy. Clear? As we know, alkali metals have very low ionization enthalpies and does not possess metallic characteristics under normal conditions. Now, it also shows some resemblance to halogens, like halogens having electronic configuration Ns2 and P5 and belong to the 17th group of the periodic table. So, if we compare the electronic configuration of halogen and hydrogen, then it is showed by one electron to the corresponding noble gas configuration helium, that is 1s2. Simply we can say halogens gain the one electron and acquire the noble gas configuration. In the same way, hydrogen will also gain one electron and acquire the nearest noble gas configuration like helium. Like halogens, it gains one electron to form uninegative ion. Its ionization enthalpy resembles more with halogens. Like halogens, it forms a diatomic molecule, combines with elements to form hydrides and a large number of covalent compounds. But in some of its properties, it shows the dissimilarities to halogens. In terms of reactivity, it is very low as compared to halogens. Halogens are most reactive non-metals. But if we compare the reactivity of hydrogen and halogen, then reactivity of hydrogen is low as compared to halogen. In this way, we can say it is unique in behavior and therefore best placed separately in the periodic table. Dihydrogen H2 Occurrence. Dihydrogen is the most abundant element in the universe. 70% of the total mass of the universe and is the principal element in the solar atmosphere. The giant planets like Jupiter and Saturn consist mostly of hydrogen. However, due to its light nature, it is much less abundant, only 0.15% by mass in the Earth's atmosphere. In the combined form, it constitutes 15.4% of the Earth's crust and the oceans. In the combined form, besides in water, it occurs in plant, in animal tissues, carbohydrates, proteins, hydrides, including hydrocarbons and many other compounds. Isotopes of hydrogen. In the lower class, we have discussed what are isotopes. Atoms of the same element having same atomic number but different mass numbers are known as isotopes. Hydrogen has three isotopes, namely protium. It is written as 1H1. That is, its atomic number is 1 and its mass number is 1. Deuterium. This is 1H2. That is, mass number is 2 and it also be written as capital D. And tritium 1H3. Its mass number is 3 or it can also be written as capital T. These isotopes differ from one another in respect of the presence of neutrons. Actually, the difference in the mass number is due to the difference in the number of neutrons. Ordinary hydrogen, that is protium, has no neutrons. Deuterium, also known as heavy hydrogen, has 1 and tritium has 2 neutrons in the nucleus. Only tritium is radioactive. Now, what is the meaning of this radioactive? That is, it emits beta rays. Okay, and its T half, that is half-life period of this radioactive tritium, is 12.33 years. The predominant form is protium. Terrestrial hydrogen contains 0.0156% of deuterium, mostly in the form of Hd. The tritium concentration is about 1 atom per 10 to the power 18 atoms of protium. Since the isotopes have the same electronic configuration, they have almost the same chemical properties, because chemical properties depends on the electronic configuration, on the number of valence electrons. The only difference is in their rates of reactions, mainly due to their different enthalpy of bond dissociation. Now, if we compare the bond enthalpy of hydrogen and deuterium, then you can see hydrogen bond enthalpy is 435.88 kilojoule per mole, while for deuterium this is 443.35 kilojoule per mole. In this way, we can see for hydrogen bond enthalpy is low, so hydrogen is more reactive compared to the deuterium. However, in physical properties, these isotopes differ considerably due to their large mass differences. Okay, thank you. Subscribe my channel to get the new video from this chapter.